Hello, in this video we are continuing our discussion of section 8.4 on other convergence tests, but now we are talking about day 3, in which we are discussing the root and the ratio tests. Specifically in this video we are working through example 6, which says to test the series, the sum from n equals 1 to infinity of 10 to the n over n factorial for convergence. We have just talked about just seen the ratio test in the notes, so you can guess pretty easily that we're going to be using the ratio test here. And this solution has been broken up into a few steps. So in this video, we are just seeing step 1, which says to set up and simplify the ratio a to a sub k plus 1 over a sub k, or in this case, an a sub n plus 1 over a sub n. And we do have some magnitudes there. So a sub n plus 1 is going to be 10 to the n plus 1 over n plus 1 factorial, and a sub n is going to be 10 to the n over n factorial. So now this is a complex fraction. If we simplify it a little, we'll have 10 to the n plus 1 over n plus 1 factorial times, n factorial over 10 to the n. And if you'll notice, all of these terms are positive. 10 raised to a positive value is positive, factorials are positive, so we can actually just drop off the absolute values for some simplicity here. And I am going to rearrange the order here so we can simplify some stuff more. I'm going to take my powers of 10 and write those in one fraction, and then write my factorials in another fraction. So we have 10 to the n plus 1 over 10 to the n times n factorial over n plus 1 factorial. So to simplify our first fraction, notice that 10 to the n plus 1 is the same thing as 10 to the n times 10. So that means that our 10 to the n's will cancel out in both the numerator and the denominator, and we're just left with, very simply, a 10 there. So we are going to have a 10. All right, now we need to simplify our factorials, and that gets a little bit more complicated. As it was already written in the notes, if you are not comfortable with factorials yet, please see that discussion that I posted as a link. There are also lots of good resources online. If you would like help finding those resources, feel free to post a question in the discussion forum, and I would be happy to find them. Of course, I'm sure you could just Google factorials and find some good explanations that way. So for n factorial over n plus 1 factorial, to help us simplify this, I'm going to write a few of the terms. So this is sort of a little side note here. Notice that n factorial is equal to n times n minus 1 times n minus 2, and so on and so forth until we get down to 1. That's our denominator. N plus 1 factorial is similar, except it starts at n plus 1. So this is n plus 1. Then we subtract 1 from that to get to n. We subtract 1 again to get from n minus 1, and so on and so forth until we end. Well, if you will notice, we have a lot of common factors between the numerator and the denominator. N is in both the numerator and the denominator. N minus 1 is in both the numerator and the denominator. If we had written this out here, we would have had an n minus 2, which would cancel out there, the 1, the 2, the 3, and we can kind of assume that all these dots cancel out as well. So if you'll notice, all we're left with is an n plus 1 in the denominator. So we will take that then and divide 10 by n plus 1. So this is the simplest form of our ratio, which completes step 1.